Hey folks, okay, now that we've got type checking and our data types and all our basic stuff and ifs and cons and whatnot tucked away, we can actually start working on function definitions and start getting into some real Lisp writing here. So I want to get into how you define functions, how you call them, some of the things to expect in terms of parameter handling, documentation strings, a whole bunch of different bits and pieces here. Okay, so the function defun is the one that's used to define other functions. So essentially you pass a bunch of parameters to defun telling it how to build the function that it wants to create, how to define the function you want. So it expects 3 or more parameters. The first one is the name of your new function, and it can't be a function that's already been defined. The second one is the parameter list that your function expects, and then all of the rest are the statements that the function is supposed to execute as its body. So if you wanted to create a function that was going to take a single parameter x and return its square root, and maybe do a test to make sure that x was actually a number first, then we'd say defun, the name of our function, square for instance, our parameter list, so x, so we're saying square expects a single parameter x, and again this has to be in a list form, and then the body. So the body is saying, okay, if x is a number, return the square of x, otherwise return nil. And again, our final bracket to close off the defun. And so you can go through, and again, when we call this, we'd call square and pass it a value, and it would go through and execute this on whatever it was passed. Now, one of the things that you can do is inside your function, you can give it a string as the sort of first field after the parameter list, if you like. And this is treated as a documentation string, just like a description of what the function is supposed to do, essentially, like a little tiny user guide to how to use the function. So, one-line help, if you like. So if I had some function foo and I wanted to give a description of it, again, defun, foo, whatever the parameter list is, and then I could provide this string, and in this case, foo just takes whatever you gave it and returns it. So foo just returns whatever you pass to it. So you can give a string as that first thing, and then again, the rest of the statements in this defun would be whatever foo was supposed to do with x. And the last thing is the value that foo actually returns. Now, to actually look up the documentation string associated with a function, you use the documentation function. So you documentation, the function that you want to look up, so a single quote and the name of the function, and then a single quote and the keyword function. Documentation can work with other things. So we're saying we want to look up the documentation for foo as a function. So let's have a quick play with that just to make sure we can get some of this actually working. So let's, I think in my stuff, we had a function definition. So in this case, I'm going to have a function called echo params that just expects 2 parameters, x and y, and all it's going to do is print out to standard output the 2 values it was passed. So my documentation string, this just repeats the 2 parameters you passed. And then the body is just going to be a format statement in this case. You passed x and y. So if I wanted to try this out, let's fire up GCL. Let's load mystuff.cl, right, the file that contains it. Let's give it a whirl. So let's try echo params, 5 and 2. And you passed 5 and 2. Okay. And again, remember that format returns nil, so the return value from the echo params function is nil. So if we wanted to look up the documentation string for this, again, we say I want to look up the documentation for echo params, and echo params is a function, and again, it gives me back the documentation string for it. So, Alrighty. Now, you can have a whole slew of statements in a function. It's not pure functionally, but it's practical. So again, what we would see then is your defun, the name of your function, the parameter list it was expecting, the documentation string, and then it could have a whole slew of different statements in it, and it's going to run through them in sequence, and then the return value for the function will be the value of the last statement it runs. So in this case, it's doing a print saying, enter a number, and then it's doing a read and multiplying that by x, the parameter that you gave it, and this is the last statement it's running, so it's returning the result of x times whatever it read in. Now, of course, we better hope that what they typed in was actually a number, or what they typed in was a number, and what was passed as parameter x was actually a number, but we'll play with type checking in just a second. So this is a pretty typical layout. You've got your function, again, name, parameters, documentation string, and then just whatever sequence of steps you want it to run through. Now, of course, you want to make sure that the things that you're working on actually have the appropriate data types for the operations you're performing. So usually what you're going to see is the body of the function is, maybe a couple of setup steps, but there's usually going to be a cond in there that does some type checking. So let's suppose that I wanted to have a function that checked to make sure x and y were both integers, and if they are, then it's going to return x raised to the power of y. Right? So my cond is going to do the error checking first. If x isn't an integer, I'll bail out. Maybe I print an error message and bail out. And if I get past that, then okay, well, else if y isn't an integer, return nil or display an error message. I'm missing a bracket there. And then the default case is to actually do the work, which in this case we'll call that exponent function and raise x to the power of y. And since this is the last statement in the cond, this is the value that's going to get returned. Well, if we get that far, right? If it didn't hit one of the error cases. Now, again, we have to think about our bracket matching. Make sure that each of these things, right, we've got a condition to check and then a value to return if true. Right? And so we've got this pair that's condition and value. We've got this pair that's condition and value. We've got this pair that's condition and value. And then we close our cond, and then we close our defun. Right? So you do have to be fairly aware of the parameter checking and your type checking when you're starting to, or your bracket checking and your type checking when you're playing with this kind of thing. And again, if I was to actually go off and type this in, it's going to yell at me because I'm missing one closing bracket. All right, a couple of things to watch out for. We mentioned that defvar is effectively creating a global variable. It's not exactly what it's doing, but that's pretty much the way we can treat it for the moment. So we don't want to use defvar inside a function if what you want is a local variable. Right? If you use defvar, it's creating a global. Similarly, if we use a setf on a variable that doesn't exist yet, so a setf on some new variable name, that has the same effect as our defvar here. So if you use setf on a new variable name, it's effectively going to go through and create a new global variable and set that value. So again, you want to be careful not to use defvars and setfs inside a function unless you're very careful to make sure that the setf is only referring to either the function parameters or to local variables that you have actually declared. We haven't looked yet at how to declare local variables. So let's just have a quick play with that just to kind of confirm some of this behavior. So in this case, I think I created a script that's got, oops, I should actually show you this, huh? Yep. I've lost my copy of it. Okay, so we've got a script that's got a function definition in it. So we've got function f, and in f, I'm using this setf on a variable I. Now, I doesn't exist yet, so it is actually creating I as a global variable here and initializing it to 10. And then we do some checking, say, okay, well, if x is a number, then we'll print out I times 10, otherwise, or we'll return I times 10, otherwise we'll print out an error message saying, oh, you didn't pass me a number. So if we actually try this out in our script, so we'll call f of 6 and see what that does. And then we'll try printing out I just to see if I really does get created as a global variable. So if we give that a whirl, oops, then it does in fact go through and, ooh, what did I do with the f? That doesn't look right. So f of 6 is whatever it happens to be, and it does print out that I is 10. So it is showing that I does exist as a global variable. Let's go back and take a quick look at what I did there. Oh, instead of multiplying x by I multiplied I by 10. That's what's going on there. So we should probably have done something like this. Yeah, okay, that looks more reasonable. But again, be aware of what's going to happen if you're using setfs on undeclared variables, or if you're using defvars inside a function. Now, for local variables, the way we do it is using a let block. So let allows us to define a variable that exists in a particular scope. So it just exists from the beginning of the let block to the end of the let block. So the way we do it is it's let, and then we have a list of pairs. These are variable declarations. We've got a list of variable declarations. Well, a list of local variable declarations. For each of them, you give the name and its initial value. So this here is saying, okay, inside my let block, I'm declaring one variable A with a value 5 and one variable B with the value string foo. And then after that list of variable declarations, you have all of the statements that you want to execute inside the let block. And what let returns is the value of that last statement. So this is going through, and it's got a format statement where it's printing out the value of B, so it's going to print out B as foo, and then it multiplies A by itself, so that's going to be a value of 25, and it returns a 25. So again, let is just a regular old function, so you can use it any place you would use any other function call. And so with a function, if you want local variables, the way it's usually going to look is something like this. Right? I'll have my defun, the name, the parameter list, the documentation string, and a let block with any local variable definitions. And then whatever I'm going to do as the body of the function. Now again, we want to be careful about getting all our brackets to match here. So in this last one, I've got the pair for that final condition, if true, return nil. I've got the bracket to close the cond, a bracket to close the let, and then the bracket to close the definition as a whole. So again, pick an editor with bracket matching in it. There are a bunch of other options for parameter passing that we'll get into later. We'll look at the use of special keywords for dynamically scoped variable. We'll look at how to set up optional parameters. We'll look at how to set up a variable number of parameters. We'll look at keyword parameter passing. So we'll look at a whole bunch of different options. We'll look at a way to have a single function return multiple different values without sticking them in a list. So all sorts of other options that we'll get into later, but at least now we have the basics of declaring and using our own functions. All right, we'll get into actually applying some of this stuff in our next session.